Hey everyone, I just wanted to include a video that explains the 6.2 notes you read for Thursday's class. And this is about linear transformation of random variables. I have a few questions about just probability distributions of random variables in general. So I'm going to kind of go slow motion through all of this additional example. So starting with histogram to just finding the mean and standard deviation. So really go through everything before I even start linear transformations. So this is about El Dorado Community College. They consider a student to be full-time if he or she is taking between 12 and 18 credits. The number of units X that a randomly selected student is taking has the following distribution. So the number of credits for these full-time students are 12 to 18, and the probability or the proportion of students that take that many credits are provided below those number of credits. So if I want to make a histogram of these, I did one in my calculator. So here, if you notice, I entered the units or the credits in column 1 of my calculator, and I entered the probabilities in column 2. This is easy enough to do without a calculator. Just so I'll show you my solutions copy. So there's my histogram that I made by hand. So if you notice on the histogram, my x-axis, that's the credits or the units. And then the y-axis are the probabilities that went along with it. It's not perfect, that's fine, but you get a general shape of this distribution. Almost looks a little trimodal where it's high on the outsides and in the middle and kind of low in the center. So if I go back to my calculator, I just made one that looks a little bit nicer, but here's each credit, and the probability is the height of those bars. Then in the same example, part B, it says find the mean, variance, and standard deviation of X. So the mean, variance, and standard deviation of this table at the top of the page. So again, your calculator does that for you. So there's my data, the units and the probability of each. So once that's in there, just go to a calculator page. You go to Menu, Statistics, Stat Calculations, and we're going to do one variable statistics. Keep the number of lists as 1. The X list here for us is the units. I'm kind of already ahead, that's why there's more variables in that X1 list. And then the probability is going to be our frequency list. And then click OK. So here is our mean of the distribution X bar. And then sometimes we kind of get confused whether we use SX or sigma X. Well, SX isn't even listed, so it's not an option. So the standard deviation here is 2.056. It's the sigma X. And then the variance, I think one of you guys told me this, ends up being this at the very bottom. Or it's the same thing as if you square the standard deviation. So if I go back to my answer key, there are those same numbers for this probability distribution. So that was really 6.1. If I scroll to part C, part C says, it adds additional information. Tuition for a full-time student is $50 per unit or $50 per credit. And they're going to call this new random variable T. So it's not in the document, but really, if you can see what I'm typing, T is going to equal $50 times each X. So I'm taking literally each X value and multiplying it by 50. So the original, if I scroll back to the top, the original number of units was 12. I'm going to multiply that by 50 to get the cost for that student with 12 credits. So 12 times 50 is 600. So that's the new value in my table at the bottom here. And then so on. 13 credits would be 13 times 50. And you end up getting this distribution. So notice my tuition now is 50 times each original value. So each original value is multiplied by 50. And it's kind of interesting histogram-wise. If I make a histogram of that data, let me go to a new page here. I'm going to call this tuition. I think I already have it in there. tuition is going to be 50 times, I think I called them units, so it's going to fill that list for me, but the probabilities are still the same. And if I make a histogram of this real quick just to show you. I hope it changed my scale a little bit, but the shape of it, it looks a little more spread out, but the shape of it is still, you can see that same trimodal shape. Let me pause this video and alter those bin widths. All right, so I just changed the bin width so you can see the shape. So if I kind of toggle back and forth between my histograms, I mean, here's histogram 1. We kind of mentioned it was trimodal with the hump on the left, kind of a big hump on the right, and one in the middle. And if I go to my new histogram, it has the exact same shape. So you kind of see that multiplying a variable, so multiplying the units by 50 is not affecting the shape. And that's really the first getaway from 6.2. Multiplying by a constant will not affect the shape of the distribution. Well, what about center? What about spread? So if I do another one variable statistics, let's see what happens to shape and spread. So now my X is tuition. My frequency is still probability. And I get a new mean. So the new mean is 732.5. I get a new standard deviation. And obviously I'll get a new variance. So I go back to my answer key here. So there's my new mean, my new variance, my new standard deviation. And guess what? They are the old mean and old standard deviation just times 50. So in part 1, I can zoom out so you see them both. Sorry, in part B, the old mean was 14.65. Well, 14.65 times 50 is my new mean. So multiplying by a constant multiplies the mean by that same constant. And if I look at my standard deviation, so my standard deviation was 2.056. If I multiply that by 50, guess what? That's 102.804. So again, multiplying a distribution by a constant is going to multiply that distribution standard deviation by the same thing. And something that's a little bit unique, if you look at the variance, again, variance is sigma squared, 4.227 is not, obviously, 10,568.8. This should make sense because variance is standard deviation squared, so I'm not multiplying by 50, but if I want to find the new variance, I'm really multiplying it by that 50 squared to get the new variance. Variance, we talked about it first semester, not that important to us. As long as you realize the mean and standard deviation are multiplied by that same constant, or in other words, center and spread are affected by multiplication, that's good enough for AP. Let's look next at what adding a constant does. Or at the bottom of this, I have this posted in Classroom. At the bottom, it says what's happening here. So the shapes, when multiplying by a constant, stays the same. The mean becomes 50 times bigger than the original mean. And the standard deviation becomes 50 times bigger than the original standard deviation. So pretty interesting how that works. The shape, let me just go back to shape a little bit. The shape's the same, but if you look at the scale, it really just shifted up. Because all the units, the original units became 50 times as big. But the shape stays the same, it's just kind of shifted to the right. And we're going to see something similar when we add or subtract a constant. All right, on to adding a constant. So same problem, same college, but now that tuition that was 50 times the units, we are going to have an additional tuition charge, a student fee of $100 per semester. So let's C equal the overall cost for a randomly selected full-time student. So the probabilities stay the same. They're based off of those original credits. And then in the last problem, we multiplied each of those credits by 50. And now on top of that, we're going to add 100. So I'm really taking my last distribution was T, and I'm making this new distribution C, which is T plus 100. So what happens to these overall costs, the 600 from before is now going to become 700. The 650 from before and the previous distribution is now going to be 750 and so on. I'll show you that in my solutions here. So here's that new distribution where I'm adding 100 to the previous one, which I also include here. That means it was 50 times the original and then plus 100. So histogram wise, just to save a little time, here's my new histogram. Notice the x-axis is now all of those tuitions, but plus that $100 student fee. And lo and behold, the shape is the same. It just shifted up 100. So all of these bars are just 100 higher than the previous. So no change to shape. Let's see what happens with mean and standard deviation. So new list, I'm going to call this variable cost. And cost is going to be tuition plus 100, and I'll fill that. And this is still going to be prob. And I already showed you the histogram, so let's just jump to the one variable statistics. And now we're going to do cost and prob. So let's look at our new mean. So the old mean, let me look back. The old mean for the previous was 732.5. So my new mean, guess what, is 100 more because I added 100 to it. So the mean, or the measure of center, is added the same as it was to every value in the distribution. So adding is going to affect the mean. Let's look at my standard deviation. Here's my new standard deviation. The old one was 102.804. Well, the standard deviation didn't change, so adding does not affect spread. Multiplying affects spread. Adding is only going to affect the center. So if I go back to my solutions, last thing about 6.2 with linear transformations is adding a constant, the shape doesn't change. Adding a constant, the mean is added by the same constant. And lastly, standard deviation and variance also won't change. Hope this helps clear up 6.2. Let me know if you have any questions about the 6.2 problems for Friday.